started this buffer overflow attack. And did anyone try that thing where you have 5 bytes of A and 4 bytes, 2 byte integer B, right? So initially this is all null, which means 0, 0, 0, and this is initially 4. Okay. Now this is each is a byte. Okay. So if you want to break it up, this is actually what? If 4 is 0, 0, 0, 0, 1, 0, 0. So that's how it is. Okay. Now, I'm running out of serial code, so please excuse me. So now you are trying to replace this string A, set it to be something, say, maniac. Okay. And we are looking in the context of C. So the last character in a string is actually what? \0. You can assume it is just null or 0. Okay, so it will be like 1 byte of all zeros. Right? So if you now we have to know this is the low memory end, this is the high memory end. Okay. And we are following a big Indian architecture in this example. So again, so what is a big Indian architecture?
The big end starts on the low end.
Which one?
The big end starts on the low end.
128
At the end.
128 is at the low end.
Low end, yeah.
Right. So this is actually a 2 byte integer. Okay. So if you break it up, this particular B, it's going to start with 1, 2, 4, 8, 16, 32, 64, 128. This is 1 byte. Right? 8 bits is 1 byte. And then you're going to continue. Something like this. 1, 2, 3, 4, 5, 30, I believe 32, 7, 68. Right. Alright, so these are the 16 bits or 2 bytes of B. Okay? So that's what we have crisply represented as B over. Okay? So this is B, the 16 bits of B. Now the 4 is actually filled like what? The 4 is actually like this. So everything preceding that is 0. So that is how 4 is really filled up in memory. Okay? So now we have to know for an integer, this is the way you represent in memory. So this is the low memory end. This is the high memory end. So since you're following a big Indian architecture, the least significant bit is at the high memory end and the most significant bit is at the low memory end. Okay? So now for character strings like this, we can also say what is the most significant byte and the least significant byte. Since this \0 really doesn't add any significance to the string, this is called the least significant byte and the first character is called the most significant byte. Okay? So given a string, you can also say what is the most significant byte of the string and what is the least significant byte of the string. Okay? So now if you want to fill up this A, which is 5 character array or byte, so in what order you will fill up that? Considering all these circumstances we are given. So big Indian architecture, you want to fill up that 5 byte array A with maniac. So how do you fill it up?
The M will start on that end.
M will start at this end. Why? M is the most significant byte. Big Indian architecture, so the most significant byte will be at the low memory end. The big guy goes to the low memory. Remember I told last time?
Yeah, so they're gonna be 128.
Yeah, so this is each is a byte actually. I have not broken it up. I have broken only B as 2 bytes. Okay. So we're going to fill up this maniac. So M is going to be here. So this is a byte. Okay. And this is a byte. This is 1 byte. This is I. This is A. And this is C. Remember, C is also 1 byte. You need to know, especially ASCII value of C, which is given to be what? The ASCII value of C is
3, 2.
Huh?
0, A, 1, 3, 2. Because it's going to be 0, 1, 2, right?
No, C. The ASCII value of C is, I believe it is, if you look at the, if S is 83, I think it is 50. S is 83, which is 18. So this is what? 5, 65. So the ASCII value of A is 65, right? Or 64. You guys don't know, remember ASCII values? No. C is 67, yeah, A is 65. Alright, so B is 67. We need to know that here because why we are interested in the ASCII value of C? Anyone tell? Because you see, C is written actually in the memory space of B because maniac cannot fit within this 5 bytes. M-A-N-I-A, then it overflows and overrides the value of B. Alright? So B is overwritten with the C, and what happens to this last 8 bits?
8.
Overwritten with those backslash 0. So it will be all zeros. Okay? So it will become 0, 0, 0, 0, 0, 0, 0. Right? So that's why I broke it up like this, because now we need to fill up the 16 bits with this C and this 8 bits. And we just know C is 67, right? So with respect to that particular byte, C is a byte, isn't it? So, and we know it is 67. So write up 67 in binary. So what is 67? It's going to be 0, 1, 0, 0, 0, 0, 1, 1. Be quick in converting from decimal to binary. So this is byte 67 in binary, right? So now we need to write that 67, this 8-bit binary over here, and this 8 bits over here. So together they make up 16 bits, right? So those 16 bits have to be represented here. So again, this issue of what order you fill it up comes in, because we need to know it's a big idiom or little idiom. This is a big idiom, right? So where does the last second byte starts? So this is 1 byte, 8 bits. This is another byte, right? 8 bits, right? Within this byte, you have to know what is the most significant bit, like how to map this here. right? This is what most significant bit, isn't it? This will be at the low memory end, right? So this is going to be a 128, this is going to be a 64, this is going to be 32, this is going to be 6, 8, 4, 2, 1. Within that byte, right, we have to be able to break it up into exponents of 2. So that 67 will be actually represented like this, right? And that other byte, like as I wrote there, it is this 128, same thing, 128, 64, 32, 16, 8, 4, 2, 1. So as far as this byte is concerned, this is what the low memory end, this is the high memory end, because memory always increases linearly, low to high. So this is the low memory end for this. With respect to this byte, this is the high end, and then we proceed from there. Clear? So it's low with respect to this byte, low, high, and low, high. Overall, it is low and high here. Alright? Clear?
Mm-hmm.
So, what is all these 8 bits now? Zeros. Good. So, if someone, as a programmer, will try to print the value of B and they expect it to print the original 4, it won't print 4 because originally the value of B was 4, right? But now we overwrote it. This is now the value of B. So, you should be able to calculate the value of B as a 2-byte integer. So that's why we wrote it up to 32768 because you see there's a 1 more here for 16384. So what, can anyone add it up and tell me what's the value of B? There's a 1 for 16384, right? There is 1 for 512. There's a 1 for 256. So we have to add both 3 and get the value of B. So that should come out to the 17152. Okay. So this is the, if you have written C programs, sometimes if you do you print out values, you will get some strange numbers like this. That's some because of this problem. Is that clear? So this is the standard question. So for the upcoming exam, I could give you a startup thing like what I have here. A all zeros and B is an initial value 4. And let's say if I write A with one set A to be maniac, there's an overflow, like what we discussed, and it overrides this B, the 2 bytes, and the value of B changes to something else. So you should be able to find what's the new value of B. Right? And you should also know how to do it in the big Indian context as well as in the little Indian architecture. So I have 2 more examples here. We'll do one, and then you can practice the other one. Alright, since we did big Indian, we'll go to a little Indian and see how to do that. Alright, so we are given, again say here, 3 variables, A and C are integers and B is a string. So B is initially set to a null string, so it is 0, all zeros. Okay, so as I showed here, this is B is all zeros. A is 140 and C is 199. Those are integer values of A and C. Okay. So this is a low to high end. So this is the low memory end and this is the high memory end. And remember what we are dealing with here? Little Indian architecture, right? So with Little Indian architecture, the least significant bit is in the
Begin.
low memory end, L and L, right? So if you want to represent this 140, the initial value of A as a 2-byte integer, you have to be able to represent A. So this is what I represent A. These are 16 bits for A. From 1 to 32,768. Okay? So write 140 in binary. So once you have exponents of 2, you can fill it up and write 140, right? So 140 is going to be starting from the MSB, you go here, right? 128 is 1. And then you have to account for 12 more. So 8, 4. So that is 140, right? 4 plus 8 is 12, 12 plus 128, 8 is 140. So the remaining will be all zeros. So that is your A. And B, as I said, is initially 0. But you should know where is that backslash 0 getting in, because it's good to know that, because later you need to know how to fill up B. Remember, as I said, this is a least significant byte, right? The backslash 0 is least significant byte for string. So as far as B is concerned, this is a low memory end, because memory starts from there, low memory end, and this is a high memory end. So backslash 0 gets into the low memory end, and the remaining zeros are filled up like this. So this 0 is actually here. This 0 is over here. So the leftmost 0, the most significant byte, is actually here. Okay? Then 199. So again we continue. So since I don't have space, that's why I wrote up here. Okay? So this is continuing from here, going all the way to the high memory end. So the least significant bit is at the low memory end for C, all the way to this, right? So 199. So start again from here. 128 plus 64 is 192. Then you have to add 7 more, so 421. Okay, so that is 199. So this is the initial setup, right? So given A, B as a null string and C is 199. So this is the initial values of the variables in the memory. So now, any questions so far on the data?
Dr. May, why is the B value a part of it and the null value?
That's like initial, just to play with, see how the overflow impacts the neighboring values. I set it up to be initially null, so that now when you replace it to the string, like we had that, the C overrides the neighboring variable. So that's just to illustrate the buffer overflow.
Okay.
You could have any initial value for a string. Okay. So I'm going to replace that B with medals. Right. So this is a string I want to replace it with, again with a backslash 0 at the end. So again, as I said, this is the least significant byte, alright, and this is the most significant byte, right? So again, memory increases from low to high, right? So M will be at the, M is the most significant byte, isn't it? And this is Little Indian architecture. Little Indian means what? The least significant byte is at the low memory end. The most significant byte is at the high memory end. So our M starts with the B, right? So this is the high memory end of B. So M, E, D, A, L. Now you see the S really overrides A. If you go from high to low end, right? So this is the most significant byte. You start with this, right? And then M, E, D, A, L, S. Yes?
I'm sorry, I'm sure I probably said this before. So the letters that are inside of the sequence B, like metal,
They are not broken up. They are not. Huh?
That's like a key or something?
These are these ones.
Yeah.
These are the characters.
I mean, it's given though, right?
It's given.
Okay.
Yeah.
Just make sure.
I got a
And
question.
they are not broken up into 8 bits. See, these are broken up into 8 bits because we're interested in the values, because the impact. Because you could break it up into, because this is actually represented in binary as an ASCII value of M, and you have to do all those things. But that's what we do here. We are not really interested in this because it's no use. You have to break it up. It's going to be as it is. Okay. Good.
Why is the S?
Mhm.
Why is the S always on the? I mean, why did the S skip from behind the L all the way to 8?
Yeah, that's why, because as a programmer, you thought you are going to work only with strings of length 4 characters. Always in C, you will allocate one more character for this last character \0. So really with this you can allocate only strings of length 4 characters or less for B. You kind of miscalculated what would be the length of your string for B. Right.
But middle, it's 5 characters.
Yeah,
What
so
is 6? Middle, it's 5 characters.
Meadows is actually 5 plus 1, 6 plus 1, so actually 7 character string.
So it's longer than what B can hold, correct?
Right, that's why we want to say it's overflow.
Okay.
But I'm still confused. Why didn't it hit? Why didn't I go to 128? There's nothing in 128.
It is
Nah, it's a
1
part of
and 28.
128.
8 and 128.
Yeah.
Oh, the 140. My bad.
Yeah,
Okay.
so after L you are going to write S. So the S is actually overwritten in the place for A. That's overflow. Okay, so as a programmer you didn't find out what was the amount of memory you need allocated for B. So you allocated wrong memory, and when you try to fill up something greater than more than that space, it overflow to the neighboring variables. Okay. So S is actually that 1 byte. The \0 is this \0 is actually the last byte. So now you need to know how would you replace this contents of A, right? Yes.
So it was just middle with the backslash.
Middle with the \0.
Yeah, with, I know the S would be replaced by all zeros, right?
Right.
And then it would still have the remaining zeros.
Remaining will be as it is.
Okay.
Once we do this, we can do that too.
Okay.
So now we know that for this situation, the complete A is going to be overwritten. The first byte of this A will be overwritten by S. This byte will be overwritten with \0. Right? So now we need to know the ASCII value of S, which I'll give you as 83.
Oh,
Okay. Yes.
So S is like considered 8 bits, right?
Right.
That's okay.
S is an ASCII 8-bit character.
Okay.
Okay. So we need to know how to represent 83 in binary. And 83, if you represent in binary, this is going to be 1, this is 83. Okay. So now already we have this layout, so this is a low end, this is a high end, little Indian architecture, so low, least significant bit. So we have 1, 1, 0, 0, 1, 0, 1. So this is our 83. Written starting from here all the way to here. Okay? And this byte, this 8 bits, is all zeros. Okay? So now if you try to read the value of A, you have to really read from this line 1 to 32, 768. So it will come out to be, wherever you have a 1, you have to add. So you have 1 over here, so 16,384 plus 1496 plus 512 plus 256 plus nothing.
So
If
the
you add all
S
of them, you
overlooked
get
the A.
21,248.
Okay.
Any question?
I got you.
Yeah. Just a quick question. Go back real quick. I think I missed it. How is it that S is equal to 83?
That's given. The ASCII value of S is 83.
Okay.
This is the ASCII value of S. So each
Okay.
character is represented as an ASCII by its ASCII value
Okay.
in memory. Okay. Any other question?
So when you have to calculate what A is, will you start from where it starts to overflow on to however many characters?
You start with the most significant byte because that's the one you start filling up with.
No, I mean like
Yes.
when S overflows at,
Uh-huh.
and you have the 3, 2, 7, 6, 8, like it starts at that big there. So do you go, you go from there
Right.
all the way to 8, like,
Yeah, so these 2 bytes you know, right? So this is a byte, this is a byte. So S occupies a byte, so that is the first byte, and the \0 occupies this byte. You go from high to low end. So this is the least significant byte is always at the low end because this is a little Indian architecture. Okay. So if you were to consider just, we can do it as a practice if you want, but let's do that. if it was just medal slash backslash 0, what will happen?
Just the first name is
MEDAL, MEDAL. So medal is already in B, right? So this byte will be replaced with all zeros, and it's currently itself all zeros.
So
You see that? This is all zeros, right? So this is not really affected. You see that?
So you put all.
It's only affected if that big count to add up. So one during that state, that's the only time it's affected, because it's gonna be an overflow.
It depends.
Zero right there, it really just don't matter. They were just saying.
It depends on this particular example, as it asked to do it for medal backslash 0 without the S, right? You fill it up like MEDAL, and this, you can even look at this picture. This, instead of S, you replace all zeros. And if you consider the previous case, it's already all zeros. The ones really start from this byte, 128. So even though there's overflow, it's not changing the value of A. Right.
So only time it change the value if there is a one there, if you gotta override that one.
Right.
But if it's just zero, it doesn't matter.
If
Even
the
if
whole
they count-
byte is 0, you have to still watch out. If you understand what I'm telling, you have to still watch out. In this particular example, you just overwrite zeros with the same zeros. But even if you replace, 1 with something, yes, the values will change. Okay? But better work it out and see if there's some, if anything gets overwritten and any value is getting changed. But this will be the same kind of problem we'll face in the exam. Okay? So overwrite and see if value changes. You're right, but work it out and make sure. What is confused?
nothing.
Okay, scoot back a little bit. So let's say that wasn't all zero.
This is all zeros,
I
right?
know, I'm just saying, let's say it wasn't, so it's MEDAL, right?
Uh-huh.
Okay, you see where, 32,768, right there. Okay, let's say that was zero, but let's say the one next to it is a one. Okay, if the first one get override, the one with zero, it doesn't matter, because it was a zero right there, but long as that one don't get override,
It will affect the value.
it will affect the value of one. Oh, okay. But if it's all zeros, it doesn't matter.
Right.
Okay,
Got it now?
yeah, I got it.
Any other question? So, you guys can do it now for big Indian, little Indian architecture?
Yep.
Okay, so one short question for the exam, right? If I ask this, you'll do it, right? No, it said you can just do it.
Yeah.
Yeah, we got it.
Do it now.
We can do
Yeah,
it.
give it to
I don't
We
know
can
about
do it.
anybody else, but can I see you one more time? I don't.
Want one more example?
If everybody else understand, I can just go to the office later.
No, go ahead, give us an example.
Okay, let's do one big Indian. Shit. 60.
He said shit. He didn't say shit.
Go to the little Indian. Big Indian. I didn't say shit.
I'm just making sure, I'm making sure I'm here.
Okay, so okay, so I made sure it overflows. That's why it's a 3 character and shift is 4 characters, and with a backslash 0. Okay, so it's 5 characters. So same thing, 2 integers, 69 and 74, and then 4 characters, right? Big Indian. So again, low to high. So as far as the A is concerned, big Indian, so the least significant bit is the high memory end, the big guy, the fat guy is at the low memory end, right? So 32, 68, all these things. And then all your B, but before that the initial value of B is this, 0, 0, backslash 0. So again the low memory end, so this is big Indian, so the least significant byte is at the high memory end, and the most significant byte, this 0, is at the low memory end. Okay? Big Indian. Right? Big Indian, most significant byte is at the low memory end. Big guy at the low end. So as far as B is concerned, this is the low memory end and this is the high memory end for B. Okay? Clear? Then 74, again write it up from low to high. Low is at the, this is the most significant byte at the low memory end, and the high memory end has the least significant byte, right? Big Indian, again big Indian, most significant byte low. Okay? So write 74 in binary like this. So now you replace B with shift. So you see now, this is the most significant byte. So where should that S should go?
The most significant byte,
Towards the high.
it's gonna be,
Most significant byte,
Oh,
big
towards the low
Indian.
end.
it's gonna be right there.
Here or here.
Yeah.
So S, H, I, P.
E.
The backslash 0 should override really this. Right? S, H, I, P. The most significant byte at the low end, right? H, I, P, and the backslash 0 should override this. And now we have already all zeros. So even though you override zeros with zeros. So does the value change for C?
No.
No. So this is an example where the value doesn't change even if it overflows. So C remains still at 74. Alright? Here? If it is something like this, you will replace this with yes as 83, and then this will be all zeros, and then there will be a change of value. Here?